Okay, volume applications. So I did some work on this before I started, and I really feel like you should be able to do this because we've done this before, and this is just applying what you already know. But we'll do this anyway and get started together, and then you guys can do some work on your own. So we're going to be solving real-world problems involving volume. So you have to be able to recognize that the problem is referring to volume and recall the formulas. So most of you will have the ability to have the formulas in front of you. Unless you use these constantly, it's really hard to remember them all. So giving yourself a note card is one way that you can help yourself, but also using, just going back and looking at this formula and remembering what you did earlier in the packet, going back and looking at your previous work, all those things are going to help you. If you've done it once, then going back and looking at what you've done is going to just help you to remember how you solved it in the first place. So let's take a look at this. And I did a little drawing as well so that we could get a better idea of why our answers are the way they are and have kind of a prediction as to what our answers should be, so that when we do solve this, if we get the wrong answer, we can recognize that we did something wrong that doesn't make sense. Okay, so here we go. So the first thing I said was to look at the shape first. So we need to look at the shapes first because you can tell this sphere, if you were to put it in a box like this, you would see that there's all this wasted space on top, right? So this is not going to take up as much room as this one. This one really has a lot of wasted space. If you were to put this right in the middle of that box, you should fit quite a few more around in there to make a full cylinder. And then we have the cylinder. This one takes up the most space so far, and I'm going to be able to prove that when we do the work. But also when you look at this, so here we have our answers, and we have number 1, this is shape 1, is going to take 4/3 of whatever our pi times the radius cubed is. This is going to take 1/3 of pi times our radius squared. This one doesn't take 1/3 or 1/4 or anything. All right, so if you're looking just between these two, this one's definitely going to be bigger than this one. All right, and they're all the same height. They're all 3 inches by 8. I'm assuming this is by 8 as well, but we don't need to know about that when it's a sphere. We really just need to know the radius. Okay, so they're all the same dimensions pretty much. We just need to figure out which has the bigger volume. So I wrote down all of the different formulas. So 4/3 times pi times the radius cubed is going to be 1 5/10 cubed. This is 1/3 times pi times the radius squared times the height. So 1 5/10 squared times 8. And this is also going to be the same thing, only here we're not going to take 1/3 of it. Here's going to be the actual whatever we get for the answer. So we're going to get our handy dandy calculator because we're going to need it, and we're going to get started. So on our calculator, we want to make sure that we can go to the scientific portion, because that's the only way we're going to be able to, we need all of our different little numbers that we're going to use. We're going to look for y to the x because that will help us be able to figure out how to find the cube of something. So we're going to start with this one right here, and I'm going to start by cubing 1 5/10. So 1.5 x to the y 3 equals, okay, so that's 3.375. All right, so 3.375. So we want 4/3 times pi times 3.375. So I'm just going to write the answer here because I don't have a lot of space, so I'm just going to solve it, which means I'm going to take my 3.375, I'm going to multiply that to pi, I'm going to hit equals, then I'm going to multiply that by 4 and hit equals, and then I'm going to divide it by 3 equals. Okay, so I get 14 and 1400ths. So 14 and 1400ths, and it's inches, cubic inches. Okay. All right, let's do the same thing over here. Not the same thing, but let's see if we can solve it. So we have 1/3 of pi times the radius squared. So I'm going to do this part here. It's going to be 1/3 pi times 1.5, 1 5/10 squared, which is 2.25, and then I'm just going to multiply that times 8. So, wait a minute, 1.5 squared, all right, yeah, equals times 8 equals 18. Okay, so this is pi times 18 divided by 3. So I'm going to take 18, multiply it times pi, equals, divided by 3, equals. Okay, 18.85. All right, and then here we're going to do the same thing, only guess what? We are not going to divide it. So we already know this is going to be pi times 18. So I'm going to go back and I'm going to say 18 times pi, and I get 56.55. So the largest shape, or the one that's going to hold the most water, is here. And this is how we found our answers, is by using our formulas. Alrighty, so let's take a look at the next page then. We're going to go to extra practice. There are 8 on here, so I will do, I'm going to mix it up a little bit. Let's do, okay, I'm going to do 5 through 8, and you guys can do 1 through 4, okay? All right, so, there we go. It's rocking around there a little bit. Okay, so number 5. So soda costs 5 cents an ounce. How much would 8 cans cost? Okay, this is really frustrating. So they're giving us in inches, and we're supposed to go to ounces, and we have no idea what the heck is going on. So we're just going to go through this a little at a time, and then we might have to do some looking up of things and figuring it out that way. But let's figure out what our volume is first, okay? So remember, it's a cylinder. So a cylinder is, the volume is going to equal pi times the radius squared times the height. So we have pi. The radius is 1.3, 1 3/10 squared, times 4 8/10. So we're going to do 1.3 first. So 1 3/10 squared is 1.69. I'm going to take that and multiply it times 4 8/10, and I get 8.11. So I'm having, let's see, this is going to be pi times 8.1. So I'm going to multiply that times pi equals, okay, so we have 25.5 cubic inches. Now, that does not give me ounces. I can't go from inches to ounces because inches is a measurement and of solids. Ounces is a measurement of liquids. So what I'm going to do is I'm going to just have to say that instead of this being inches, it should be ounces. I'm just going to call this ounces, and we're going to have, let me see. I'm just going to make sure that I can't go from one to the other. I'm fairly certain that that is true, but you know what? I've been wrong multiple times before, so. Oh, never mind. A cubic inch is about a half of a fluid ounce. So if I say, I'm going to put in my number of inches here, and I'm going to put in, my inches are 25.5. 25.5. So that gives me 14 fluid ounces. You know, that's just silly. It's a good thing I have a computer in here. Okay, so this is actually 14. So it's 14 ounces. And at 5 cents an ounce, it's going to be times 5 cents. And we're going to get that. So 14 times 0.05 is 70 cents, and 70 cents per can times 8 is $5.60 per can. It's really, really crazy. But there you go. Okay. So I guess you divide this number here by 1.8, but we haven't even learned that yet, so cray. Okay, so let's go. All right, Marcus is digging holes to plant trees. If he digs 4 holes like the one below, how much dirt did he remove in all? Well, that seems kind of, well, I mean, that's sort of how we dig holes, right? We don't always dig them like a nice, square deal. We dig them however we can, and sometimes they get pointy at the bottom. Okay, but let's figure this out. So, it's a cone, and our formula for cone is volume, oh my, equals 1/3 pi times the radius squared times the height. Okay, so we have 1/3 pi. The radius is half of 3 feet, so just 1 5/10 feet times 4 2/10 feet. That's our height. Okay, so we'll go back and we'll do that again. So 1 5/10 squared is 2.25. We've done that before. And 2.25 times 4 2/10 is equal to, okay, so this is going to be 1/3 of pi times 9 45/100. Now I'm going to say this times pi equals divided by 3. 9.9. 9 9/10 cubic feet. That's how much you've removed. Oh, no. 4 holes. Okay. Times 4, which equals 39 5/8 cubic feet. All right, that's how much that is. All right, I'm going to do 4 because I forgot it was 4 holes. Okay. And I got this 39 58/8. I rounded this number, but I left the actual number in my calculator, and then I just multiplied it times 4. So you might get something a little bit different than that. Maybe you'll get 40. And that'll work too. Okay. So let's do this. Jose pours 6 cups of coffee. How many ounces does he pour altogether? Okay, well, it's a good thing we still have this ounce thing, because we're going to take our cubic inches and we're going to divide it by 1.805. So I'm going to write over here that I need to use the 1.805. Okay, so 6 cups of coffee. How many ounces does he pour altogether? Okay, first of all, it is a cylinder. So we're going to go back here and do our formula of volume equals pi times the radius squared times the height. Okay, so this is pi. The radius is half of 3.25. So half of 3 25/100, 3 25/100 divided by 2 is 1.625. So let's do 1 625/100 squared equals, and then we're going to multiply that times 2 5/10, which equals 6.6. Okay, so we'll say 6 6/10 times pi equals 20.73. We have to divide that by 1 805 thousandths. Divided by 1 805 thousandths equals. So it is roughly 11 and a half. And we're doing 4 or 6 cups. So times 6. So 69. I'm just going to round it to 69. $69 ounces. All right. That's how much he's pouring all together. Alrighty. Finally, Delilah. Delilah is buying a large balloon. The cost of the balloon and helium is 2 cents per cubic inch. So how much will she pay for the balloon? Okay, so the balloon is a sphere. So it is, volume is equal to 4/3 pi times the radius cubed. The radius is half of the diameter, so that's going to be 7 cubed. So let's see if we can figure this out. So first of all, 7 x to the y 3 equals. Okay, so that's going to be 4/3 of pi times 343. So I'm going to do that. I'm going to say pi, or 343 times pi equals times 4 equals divided by 3 equals. So 1,436 and 75 hundredths. 1,436 and 75 hundredths. And it's 2 cents a cubic inch. So this times 0.02. And she is spending $28.74. Whew. To fill that balloon. It's a big balloon. That's pretty expensive, huh? Okay. All right, you guys. Those are 5, 6, 7, and 8. And you guys are going to try to figure out 1 through 4. All right. Thanks for hanging out with me.